All right, everyone. Welcome to week 3. This is session 7. So we are officially into May. We've got 3 sessions left. There's only slides for session 7 and session 8. Session 9 is just kind of a wrap-up session. Uh, it's, I mean, all the sessions, I guess, are kind of optional. So session 9 is basically just going to be answering questions, anything that you have, and then we'll be working on challenges for the night. Like there aren't any slides or anything like that. Again, if anyone wants to bring any outside challenges that they've run into that they have questions about or that they maybe think's a good one to work through class, more than happy to do that with you. Um, Ask any questions about what it's like to go to Code Platoon, be a software developer professionally, anything like that. More than happy to talk about it. Uh, and just a reminder, Wednesday we'll be leading off the class with Greg Drobny as a guest speaker. And again, he's the student services at Code Platoon, and it'll be a similar session to like what we did with Guillermo, where he'll come in, he'll talk for probably 10-15 minutes about more of like the financial and logistical sides of going to Code Platoon and answer any questions you have um, during a Q&A session afterwards. All right, so we only have really like a couple of slides tonight. We're going to talk about truthy falsy, uh, which isn't too bad of a concept, but then we're also going to talk about some recursion. And recursion is a little bit more of a sticky subject, and it's something where um, recursion can be really difficult to grasp sometimes, but it's not. It's kind of like an academic concept. You can use it, especially like if you're using functional programming languages, like if you're writing in like Scala or Clojure, things along those lines. You may use recursion more often, but most of the time when you would use recursion, say in like a dynamic language like Python or JavaScript, you're better off probably trying to solve that problem with a loop and solving it iteratively versus solving it recursively. And we'll kind of talk about that in and give some examples and show you like what happens and how quickly you can basically run out of memory when you're using recursion and you're stepping into multiple recursive calls in a recursive function. All right. So any questions for me about anything from week 1 or 2 or anything else you want to talk about before we get into the slides for this evening? Okay, so we'll go ahead and jump in. So the first thing we've got is truthy and falsy. And what that means is that each value has an inherent Boolean value, generally known as either truthy or falsy. There's only 6 things in JavaScript that are inherently falsy, right? So false, the number 0, a empty string, null, undefined, and not a number. Everything else is will return a true value. So it is truthy. And it isn't like it's good to know these, but if you forget them, like you can always look it up again. It took me a while to memorize these, and it's not again, it's like not on any quiz or anything like that to get into Code Platoon. It's just something that helps you write programs. And so if I say, let's see, let's just go ahead and do a quick if else statement. So if I say if, I'll just do this, if X, we'll say console.log. So, right? So if I just start off with the Boolean true and I run this, right, the value true for X is truthy, right? If I just change this to the number 1, right? So we're not having to say the X equal to 1, anything like that, just anything other than these 6 things by default will return true, right? They have a truthy value. And so but if I put 0 in here, right, the value 0 for X is falsy, right? And same thing if I do false, if I do an empty string, undefined, and any of those, right? So if I just put an empty string in here, right, that is falsy as well.
That's kind of tricky because if you put a false in those parentheses, then it becomes truthy.
Right. Well, because it's the string false, right? And so right, and because we're not doing any comparison here, it is just falling back on if it's truthy or falsy or not. You're right, like it looks weird, and I wouldn't set yourself up for doing something like that. If like I would never have something just return like the string false or the string true unless you absolutely had to. Like I'd try and figure out a different way to program around that. Right, so like when it's outside of the quotes, it's a Boolean. So like it becomes false, that is falsy, right? And it's just so is it 0 empty string nan undefined, the number 0 and undefined, the Boolean false. So that's 1, 2, 3, 4, 5. What's the 6th one? I think it's null.
Null.
Yeah, and so those are the 6 things that are falsy, right? And then truthy is everything else in JS. All right. And so if you're getting a false sometimes, so basically like if you're not getting what you expect, I always doing the first thing you check is like the logic, and the second is that you're not doing something that you're falling back on truthy or falsy and possibly expecting something that is truthy or falsy to be the inverse of that. All right, now for the fun part. So for anyone in class currently, have you dealt with anything in recursion yet? Do you know what it is?
No.
I have. Jesse.
Okay.
Yes, I have. This is Chad.
Okay, cool. So we've got a couple of yeses, a couple of nos. So recursion is the process in which a function calls itself. Using recursion to solve a problem requires 2 cases. And this, whenever we solve anything recursively, we will get into like, we will identify these cases when we do our prep, right? And so the first case is a base case. This is the condition at which the function stops calling itself, right? So like when you hit the base case in a recursive function, that means that you're done calling new instances of that function, and you're going to start to unwind everything. By each of the functions that you have called will start to do a successive series of returns until you basically unstack all of your recursive calls and you end up with a final answer. The recursive case is the case in which a function returns itself, right? So if we take a look at this function, and I'm just going to snag this here. Whoops. Now let's come over here with this. And I'm just going to comment these out for right now. All right, so we've got the function sum up to and number. So the base case is if the number that is in here is equal to 1, we return 1. Else, the recursive case is return number, and then basically we're returning the number, but within our return statement, we're also returning an additional function call, right? So if I were to do something like this, so sum up to 5, right? The first time through, my return statement is going to look like this. It's going to look like return 5 plus sum up to 5 minus 1, right? And 5 minus 1 is 4. So basically what happens down here is it's like calling sum up to, oops, not sum up to 4, right? And then that next time through, my return will now look like this. So it'll be return 4 plus sum up to 4 minus 1. All right, and we're going to keep going. So that one is going to look like this. Now, when we get to here, 2 minus 1 is 1, right? So that last function call is basically like calling sum up to 1, right? So this num up here would be a 1. When we come in here, instead of going back into the recursive case again, we basically hit the true part of this if statement and we actually return the number 1, right? So this resolves itself into 2 plus 1, right? So this will then look like return 2 plus 1, right? And then this is going to turn into return 3 plus, or I'm sorry, 3 plus 3. This one is going to look like return 4 plus 6. And then this one is going to look like return 5 plus 10, right? And then that final one basically then returns the number 15. And if we wrap this in a console log, there's our 15, right? And if we were to do a 6 in here, then it adds one more function call on here, right? Because the first time through it would actually be 6 plus the sum up to function call of 6 minus 1, right? So this would bump it up to 21, right? So this is solving the problem recursively, right? And we could do the same thing. So we could say, whoops, don't need to comment that. So we could say function some loop, right? And say num. And we could say let sum equal 0. And we could say for let I equal 0. Actually, I'm sorry. We could do, we don't need to write a for loop for this. We'd do a while loop for this. We'd say while num is greater than 0. We could say sum plus equals num. And then we could say num minus minus, right? And then at the end here, we could return sum. And if I do console.log sum loop, and we give it the number 5, if I wrote my loop correctly, hopefully we'll get 50 out of this as well. Yeah, and there's our 15, right? So this is solving it recursively. This is solving it iteratively, right? Like, and so we're going to, I don't know if we'll do anything recursively tonight. We may save some of the recursive challenges for tomorrow night, or even or not tomorrow night, Wednesday night or Thursday night. We're just covering the concept right now. And we will, I think it says it on, oh, come on. The challenges here, like there's a handful of challenges down at the bottom that are recursive, right? So we've got pyramid, reverse word, greatest common denominator, true default, or that, and then factorial, Fibonacci sequence, and palindrome. And Fibonacci sequence is actually pretty tough because it's a double recursive. So you call the function once the first time, and then the solution is actually requires you, each recursive case is calling two more functions. So if you think about that, right, like if you on the first call you have one, and then on the second call you have two, and then on the third call you have four, right, and then on the fourth call you're up to eight. And so very quickly you can see like where a loop takes up a specific amount of memory, and it'll keep running over and over and over again. And each time that you add an additional loop to it, like you're taking the same amount of memory. When you do something that's like double recursive, you can see, so like the time after that, right? So like at the fifth layer, right, we're going to end up looking, what is that? Right, so we end up with blocks like that, right? And then on the sixth layer through, right, it just keeps going and getting bigger and bigger. So like if you go 6 layers deep in your recursive call, you've now saved like 1, 3, 7, 15, 23, 31, and then 47, and so like 63 function calls to memory just to be able to handle this. Now think about that, if my Fibonacci sequence is something like this, right, where I say 100 or 1,000, like very quickly when you're dealing with recursion, you can run a very powerful computer out of memory, let alone whatever we've got in our, right, we've just got 512 megabytes of RAM in this, right? And so it's, again, we cover it just so you're familiar with it, but if, and even leaving, like I have not used recursion once since I graduated my apprenticeship from 8th Light, and the only reason I really used it that much during my apprenticeship was because I had to learn Clojure, which was a functional language that has no looping in it, so you actually have to use recursion to solve problems. But yeah, outside of that, it's more just so you have some familiarity with it. All right, so there's that. And if we take a look here, right, this is kind of what I just illustrated. So sum up to 5 returns 5 plus sum up to 5 minus 1. So this returns 4 plus sum up to 4 minus 1. Then we've got returns 3 plus sum up to 3 minus 1, and then 2, and so on. And then finally down at this fifth function call, we hit our base case, and then we return 1, we return 3, we return 6, we return 10, we return 15, and we get back to the original call. And so you can read more about this, like, and you can start looking at heaps and stacks and call stacks and getting into like physical computing theory and how like physical computers handle this. But again, those are all advanced concepts, and they're not going to necessarily help you make it through the application process for Code Platoon. All right, so any questions for me on either truthy, falsy, or recursion so far.
So is it really just the reason that it keeps doing the call over and over and over again? Is it just because of that call to the function and the else statement?
Yes.
Okay. Because in obviously like a normal loop, it'd just be like, okay, this is true, cool, else, do this. But that's kind of like the magic sauce, if you will, that you typically would use in a lot of base case kind of recursions. Is that kind of the idea? You use some sort of call to function with an argument or parameter?
Well, you'll never have a call to the function in your base case. The recursive case will always have the additional calls to the function. And so your base case, right? So like we're stopping this when num is triple equal to 1, right? Like we could write the same thing right here as well, right? And we'll still get 15. We'll get the same, whoops. Maybe we won't get 15 because I'm not thinking about my logic correctly. But it only does it while it's that. So sorry, we can't do that. We've got to say while greater than. Otherwise, it would only do it then. So ignore everything I said for the past sentence before this. But basically, this is doing the same thing, though, right? Like once we get to num equal to 1, right, we're done. And this is saying that once this, because of the mechanic of the loop, we're saying once num is, and I shouldn't say less than, is it less than 0? Did that give me 15 still? Yeah. What happens when I do less than 1? Well, that cut me short. Yeah, that cuts me short. So, yep. But basically, these are just our stopping points, right? So once this happens, stop looping through here and adding num to sum, right? And this is keep calling this with one number less, right? Because the same thing, like if I get rid of num minus minus, I'm not moving towards finishing my loop and I create an infinite loop. And it's the same thing here. If I don't move towards my base case, I will create a infinite recursion. And I will get a call stack overflow. We'll see what happens, right? So range error, maximum call stack size exceeded, right? And it's because, and again, this isn't going to last too long because this is a fairly small chunk of memory. I don't know if I can, yeah, it's not even really wiggling here. But if you don't move towards your base case, like you will just recurse off into infinity as well. And the only thing that stops you from recursing until the end of time is that your machine will have a finite amount of memory, but it will never finish the calculation. And we can take a look at this here real quick on Python tutor. All right, so just like normal, we take our function, we load it into memory, we come down here, we hit our first function call, right? So which is sum up to 6, right? So num is equal to 6 here, and num, so 6 is not equal to 1, so we don't hit the base case, we hit the recursive case. And we do this, we're going to return num, which is 6, plus sum up to 6 minus 1, right? So now we see that num is now 5 when we come up here, right? And again, don't hit base case, come through here, num is 4. And see where each one of these is its own separate function call, right? 3, 2. So now we come up here and 2 minus 1 is 1, right? Oops, we get one more. So there's our base case here. We hit it. Return value is 1. Return value is 3. Return value is 6. Return value is 10. Return value is 15. And return value is 21. And then that's the end of the execution. The final correct answer is 21. Right. And if we were to do the same thing here and we do this, right? So there's our function, some loop, and we're going to step into it here. And so we're in this function called some loop with the num6. Sum is equal to 0. We're in our while loop. All right, we step through here. We see that sum is now 6, num is now 5, and we're going to just keep looping through, and we're going to see it add in iteratively. Right, 18, 20, and then finally 21. We're out of our loop, and we return our sum, which is the return value of 21. So, and notice how this all happened in one function call versus like when we did it recursively, we got a sum loop, a sum loop, a sum loop, right? And so each one of those is basically having to save a full function call in memory. And so these, again, as they get bigger, they tend to exponentially outpace how much memory you're doing with a loop. All right. So any other questions that we have with this? All right, then on to the challenges. And so I know tonight I would like everyone to handle 2 strikes. So I don't want to lead off with that one. We finished with last 4 of social. We can do sum of negatives. Initials would be a good one. So here, why don't I, just as kind of a lead off as another demonstration, I'm going to do the pyramid one recursively. And then we'll get into the 2 strikes one, which is actually a like a fairly fun challenge. I like that one a lot. All right, so go ahead and fork this. Oh boy, they're upgrading things are getting more and more invasive. Let me just grab the little prep thing here. Let's take a look at the README. So using recursion, write a function that returns the total number of blocks in a pyramid with a given height. The pyramid looks like this. Basically, each row has an additional 2 blocks in it, right? So first, the top of the pyramid is just 1 block. The row underneath it would be 3 blocks. The row underneath that one would be 5 blocks. The row underneath that one would be 7 blocks, and so on. So a pyramid with 3 rows would be 9 blocks total, 5, 8, 9. So, and the formula for that is 2 times n minus 1. And top of this in our pseudocode, we will have a base case and a cursive. All right, so say console.log pyramid 3, and we'll say console.log pyramid 5. All right, we know 3 should be 9, and 5 would be so that would be, was that 16 plus that, so it would be 25. All right, so we're going to get one parameter, which is a number, and that represents number of rows in the pyramid. Return is going to be, there's one thing we're returning, which is also a number, represents number of blocks in the pyramid. See below. All right, so our steps to solve. So our base case in this is going to be this right here, right? Because this can keep growing this way, but we can never have less than one block in a row, right? Like that is the smallest a row can be. That's one block. So that our base case is when there is one block in the row. The row smaller than that. And our recursive case needs to determine how many blocks are in the specific row, and then also call it let's see here, needs to determine how many blocks are in the specific row, and then call the function for the next row on top of it. So basically going from largest row to smallest row. All right, so let's go ahead, and for this we're going to say we're going to have an if statement here. So we're going to say if height is equal to 1, return 1. All right, and so that is our base case right there, right? Like we can't have anything less than one row, or I'm sorry, one block in our row. All right, and so else we are going to need to return our number, so which is 2 times n minus 1, right? So if we have this first call is 3, right? So we would want it to be 2 times 3 minus 1 plus pyramid 3 minus 1, right? And now that's a hard-coded value for 3, and we actually need to take those out, but this is just to make it clear, right? But this is actually going to become height, right? And so the first time through, we're going to get 2 times 3, which is 6, minus 1, so 5, plus we need to know the height of the row on top of this row, right? And so that is going to be height minus 1, which is 2. So then that next function call through is going to be 2 times 2, which is 4, is 1. That's 3. And then we're going to have 2 minus 1. And then on that last function call, we are going to basically hit our base case, return 1, and then this becomes 1 plus 3, right? And then this one returns. The next time through, this becomes 5 plus 3, right? And so there we've got, excuse me, 1, 3, so that's 4. So it actually, I apologize, it would be 5 plus 4, and that's what would give us our 9. All right, so let's see if we hit it. We get true, true. So that looks good to me. It's harder to console.log these. So let's go ahead and grab these and take them over to the Python tutor. All right, and let's take a look at this. And let's just go ahead and take this one. All right, so if we visualize this execution, I get some random ads on this thing. I don't even know what, I'm sure, whatever. All right, sorry, short attention span, easily distracted. All right, so same thing here. We take our pyramid function, we load it into memory, right? We come down here, we hit our first function call, which is pyramid 5. Right, so height now becomes 5. We do not hit our base case. We step into this, right? We make our next function call, which is pyramid height 5 minus 1, which is 4. Right, we're going to keep doing this. We're going to keep going through until we finally hit this last function call where height is 1. Right, and so now we hit the true case of this if statement, which returns 1. So we're going to see this return value down here, right, where this becomes 1, and we're going to add it to the previous one, and we're going to start taking these off our call stack. Excuse me, our call stack, right? So we hit our base case, we return 1, the next function call, return value 4, 9, 16, 25, right? And then that is the final step. It's done running, that our return value is 25. All right, so again, just like another example of recursion. And the other one, we were just adding numbers. This one's got a little multiplication and some subtraction in it. So we've got some formula in there. And same thing, we could write a loop that would handle this as well. So we could solve this iteratively, like we don't have to solve it recursively, but this is the recursive solution for it. All right. Any questions after working through the pyramids challenge? Okay, so it is 6:50. Let's go ahead. We'll go over the, I think we were going to do 2 strikes. We'll take a look at this one. I'll set the breakout room up, and then we will go from there. Let's fork it. There we go. All right, so for 2 strikes, we write a method that takes in a string array of license plate numbers. The method should return a string array of any plate numbers that appeared at least twice. If none of the plate numbers have appeared more than once, the method should return an empty array, right? So if we look at this first example, 345 B317 appears right here, and it appears right here. So we return it in an array by itself. If none of these have a duplicate, we just return an empty array. All right, so this is going to basically, we're going to need some conditional logic. We're going to need an array, and we're going to need to be able to loop through our existing array and then basically exercise our conditional logic to determine what our final result is going to be. Does anyone have any questions about this before I set out the breakout or set up the breakout rooms? Is everyone comfortable doing this 2 and 2?
Well, I'm not going to be able to share my screen, so that when we have a smaller groups like 2 and 2, you might get multiple people together who can't share screen.
Okay.
That's the only concern.
Has anyone in the group solved this before?
Yeah, I have actually.
Okay. Anyone else? Okay. So 3 no's and a yes. One person can't share screen. So I will put you into a breakout room together then. And it's 5:50 or 6:53. So take a few minutes to take a break. And then basically, if we're gonna do it, I probably don't even have to move you out into your own breakout room. I'll just let you take the main room over. I've enabled multiple sharing. I'll just stop sharing my screen. Is anyone else having problems with sound? Or I'm cutting in and out?
No, I'm not. You sound fine.
Okay. Yeah, I don't know if you need to possibly disconnect and reconnect then, Michael. All right, welcome back from the 2 strikes challenge. As I said, this one's a little bit trickier than some of the ones we've done previously. We'll continue, they'll continue to ramp up a little bit as we keep going here. So let me go ahead and pull this over and we'll do our prep work here. And so we need to write a method that takes in a string array of license plate numbers. The method should return a string array of any plate number that appeared at least twice. If none of the plate numbers appeared more than once, the method should return an empty array, right? So we're going to get one item, which is an array of license plate numbers. And we're going to return one thing, which is an array of any plates that had duplicate values. All right, and so we've got 3 examples down below here. Okay, so let's go ahead and do our steps to solve. So I know that I have an array of plates. I will need to isolate plate, then want to compare my isolated plate rest of the plates to see if there are any duplicate values. Is a duplicate array that holds all duplicates. All right, so here we go. Let's go ahead and throw a console.log in here and make sure we're getting plates the way that we want to see it. All right. So there's our array of all the different plates. Normally, like if I needed to iterate through an array of items, like I would just write a for loop. However, what I'm going to do with this one is going to be a little bit different. And I know I was watching you guys work there, and you were going down the path of using an object. And that isn't necessarily something that I would recommend as far as the solution for this one. I would just create a, so we'll say let result, or we can say let duplicate plates equal an empty array, and then we can return our empty array. Right, and so if we run this now, instead of undefined, we'll just get 3 empty arrays here. So what I would want to do is probably take a plate out of here and then loop through all of the other plates and see if there is a duplicate value in there, right? Using some conditional logic. So how do I remove something from an array? What built-in can I use for that? There's actually 2. I'll take either one.
Either a pop
Yep.
or a shift.
Yep. So definitely not splice. So remove first element of the array is shift. I don't care about by index that they have pop up here. Remove the last element of the array is pop. So I'll just go ahead and do it with a pop here, right? So I can say, if I do console.log plate and a pop, right? So now I'm just getting one value, which was the last value. So let's go ahead and say, let plate to compare is equal to plates dot pop, right? And so now if I take a look at plates here, right, I've got one less item in each of these arrays. And so I can roll all of this into a loop. So I could say while plates, and I could say while plates dot length is greater than 0, keep going, right? And each time I loop through, I'm going to pop something off here. But quite honestly, because we studied truthy and falsy tonight, right? So we know that like an empty array is still truthy. So I couldn't just do it based on, say, like plates. But I do know that if I put a plates.length on there, eventually that will resolve to 0 if I keep popping things off of that, right? So I could just say this, right? And so while plates.length, and it's going to start off as like 5 or 6 or whatever, and we're going to keep looping through, and we're going to keep taking one off. Eventually, plates.length is going to be equal to 0, and then we're going to stop popping things off, right? So if I run this, did I create an infinite loop here? Oh, I'm sorry. I created my while loop, and both my curly braces are on the same line, so it was not doing anything. There we go, right? So each time I loop through, it's getting a little bit smaller, which is what I was looking for. All right, so now I can do something like this, right? So I can say, and there, I'm going to write this messy the first time, and then I'm going to take some steps to clean it up and make it a little bit better, right? So I could say, and this is going to end up being in a double loop, right? So now that I've popped it off, right? So I can say let I equal 0, I less than plates.length, I sorry, I plus, and now I could do something where if plate I is triple equal to plate to compare, now I can say duplicate. Oop, that is my finger is not in the right place. Sorry. Duplicate plates dot push plate to compare. All right. And so we can get rid of this console.log here real quick. And we can run this, right? And I get this where I only had one duplicate, but I'm running into a little bit of a problem here, right? Where I only want, I definitely have duplicate twos, but I don't want to push it into this array 3 times, right? So I only want it to show twice. And the first thing I would do to clean this up is I could get rid of this for loop. I don't need a duplicate for loop here, right? Like this is, if someone's telling you to build it with the minimum amount of built-ins, then this is kind of the way to go. Right? But without it, what I could do is plates dot contain, or I'm sorry, includes plate to compare, right? And let's go ahead and wrap this in an if statement. And if it does include it, then we could say this. Right, if we run this, oops, plates that includes is not a function. It should, let's see here. I think it is, it contains in JavaScript. Contains is not a function. Checking if array contains a value in JavaScript. Dot includes, did I just spell it wrong? I did spell it wrong. Includes. How about includes? Plate to compare. All right, so we're there. And we shaved off one of the extra ones, but it's still the same. Like if I throw some extra twos in here, all right, this is still a mess. So lastly, kind of the thing that I could do to clean this up is I could put in a compound statement here, right? And so if I do duplicate plates dot includes plate to compare, right? So if I run it this way, at this point, I should just get empty arrays again because this will never be true, right? And what I can do is I can then use a bang operator to send this to the inverse. And there's my arrays with just one element, regardless of how many times it appears. Right, and so this is how I would solve this one. If you wanted to go even past this, like you could probably solve this with a filter that filters out so that anything that only occurs once, right? So like you could probably solve this in a one line. But again, when we do these, right, like we want to work with arrays, we want to work with loops, we want to practice with it. So but this would be the solution that I'd be looking for this one, right? So we're looping through. That object is a little bit of unnecessary data conversion. So we can iterate through our initial array, remove some elements from it, do some comparison, and when we get what we're looking for, we can use some conditional logic to control when we move duplicate results into the duplicate plates that we then return at the end of this. Right, so at the end of the day, this would be a good answer here. Any questions on the steps that I went through to solve this? Nothing? Okay, so let's go ahead and pick out our next challenge here. All right, so this was 2 strikes. Sum of negatives. Let's go ahead and take a look at this one. Write a method which takes in an array of integers and returns the sum of only negative integers in the array. Okay, this will be another good one. So I will go ahead and pause the recording. I'm going to let you guys take the room over again. Someone can share their screen. I don't care if it's the same person or someone different. I like the way you guys worked with each other last time and you discussed everything. So keep up the good work on that. And if you need to take a couple minutes before you get started again, feel free to get that break in there. Let me go ahead and pause. All right, welcome back from the sum of negatives challenge. I believe the team got a solution on this one fairly easily. So we'll go ahead and go over this real quick. And we'll move on to, hopefully we've got at least one more challenge in us, possibly 2, just depending on the timing here. So grab these. Falses. All right. So write a method which takes in an array of integers and returns the sum of only the negative integers in the array, right? So we're going to get one parameter, which is a array of integers. And we're going to return a number that represents the total of all negative numbers in the array. See below. All right. So I need to iterate through my loop, or sorry, I need to iterate through my array. I need to identify negative numbers and sum them, and need to ignore any numbers greater than or equal to 0. And so I also need to all right, so let's go ahead and take a look here. So I can say let sum of negatives equal 0, and we're going to return sum of negatives. All right, and I need to loop. So I can say for let I equal 0, num array dot length. Oops, sorry. Less than num array dot length, and then I plus plus. Right, so we're going to iterate through each element array. Let's go ahead and take a look at what that looks like. So we can say console.log num array I, and make sure we get each of those numbers in there. Right, so 3, -1, -9, 2, 4, 5, 1. All right, so now we want to only take action if we have a negative number, right? So we could say if num array I is less than 0, And so now if we do this, what I would hope to see is only the negative numbers, right? So -1, -9. We've filtered out any of the positive numbers at that point, right? And so instead of console.logging it, we could say something like sum of negatives plus equals numarray I, and we're only doing this when it's a negative number. Right, and there's our two truths. All right. And this was pretty similar to the answer your guys had, right?
Roger.
Cool. All right, so let's go ahead and so any questions on any of the challenges we've done so far tonight?
No, I think that recursive stuff kind of got my brain warped, but that last one that you just went over was pretty straightforward, and you could even do that with a switch.
Yep, you could. I wouldn't though. The only time, so usually a switch state. So if you find yourself writing lots of if else statements or else if statements, so like where you have an if, an else if, an else if, an else if, an else if, that's typically where switch statements come into play. Outside of that, like if it's just an if statement that we're using here, I wouldn't necessarily I wouldn't take this out for a switch statement. Like there's no rule saying you can't do that, but if statements are far more common in code bases than switch statements are. And let's see here. So let's go ahead and pick another challenge here. This initials range. All right, we just did sum of negatives. Okay, so let's go ahead and do initials. Let's take a look at this one. All right, so write a method that takes in a string of your full name and returns your initials as a string of all uppercases, right? So Michael Jordan, and you can see those letters are already upcased. Elon Musk, everything's in lowercase, but we get EM. Everything's to upcase. Michael Gary Scott, right? So upcase, upcase, lowercase. And we need to get MGS all to uppercase, returning it as a string. So this is a pretty decent one as well. So I am going to pause the recording. We'll get you guys set up on this challenge, let you take a crack at it, and then we'll come back and explain it in class. Just a moment here. All right, welcome back from the initials breakout. We'll go ahead and run through this and go through a solution, and then we'll pick, we should have enough time to do one more challenge for the evening, and then we'll be done with session 7. All right, so we've got one parameter coming in, which is a string, which is a full name, right? And we're going to return one thing, which is a string that includes just the initials of the name, all in uppercase. All right. So example, we can say see below. All right. So we know because we're going to, there's basically multiple names in each string, we're going to need to break that apart into individual elements. So we can break our string into an array on the spaces. We will then need to iterate through the array and isolate the first initial of each name. We will then need to glue together just the initials and make sure they are all in uppercase before return. All right, so I think that's a good start for the pseudocode. So let's go ahead and take a look here. So we can say console.log. Full name. All right, let's take a look at what we get here. All right, so we got Michael Jordan, Elon Musk, Michael Gary Scott. So if we do a built-in, we can use split, and we're going to split it on the space. All right, so that looks good to me. So now I know that I can go through and I can grab the first initial here. So let's go ahead and write a loop. And I guess before we do that, we'll we'll save this to a variable. So we'll say let array of names equal this. And let's go ahead and say for let I equal 0, I less than array of names dot length I plus plus. And let's go ahead and throw our console.log in here. All right. So how do I grab a one letter of a string?
By indexing?
Right, so we can index, right? So I could do this. Right, so I could say at index of 0. Oops, I screwed this up somehow. Array of names I 0. This is yelling at me now for some reason. What did I do wrong here? Because I had put in an extra box.
Bracket.
That's why. Array of names dot length. There we go. So we've got MJ. So we could also do the char at 0. Right, so there's that. And so now we've basically highlighted the individual initial here. So we could create we could say let result or initials equal an empty string, and we could add to it. The other thing that we could do is we could assign in place, right? Like you cannot mutate a string, but you can assign it in place. So I could do something like this, where actually I'll just pop this out of here, I'll leave the console.log alone, and we could say array of names I is equal to this. Right, and so if we come down here after we're done with our loop, we can drop our console.log in here, and let's go ahead and look at array of names. Right, so we've got MJEM, right? Like we've got all of it without having to create another variable. And you can create the other variable, you can do it this way, however you want to do it. This is just one less line of code, right? And then we could say array of names dot join, right? And we're going to join it on everything, right? And then we're going to, sorry, my mouse is moving slow, dot to uppercase, right? So that's what we're looking for. Now we can pull this out of the console.log and we can return it. Right, and there's our truths. And we could, so this is, but the solution that you came up with on your own was great. Like this one would be great. If you really wanted to go crazy, like we could probably solve this in one line. I'm just trying to think here if that's the case. If let me see if I can do that here once real quick. So we'll go ahead and comment all of this out. So we could say return. Oh, we'll start as a console.log. So console.log full name dot split on that. All right, so we're there. We could also do to uppercase. We could do it right at the very beginning as well. So there's that. And then we could do for each name we could say name is equal to name dot char at 0. No, that didn't work the way I wanted it to. Let's just do. Oh, it's because I'm console.logging it and it's undefined. Console.log name. Yep, so that is working. And so we can do that. And then we could do join everything. Join undefined. Sorry, for each. Maybe that's going to trip me up there. Outside of it. Yeah, so I could switch this over to a map. And then let's see if this will do it. Go. Let's put it all back in the console.log. And sure we can do this. I'm just running into a trap on it. So console.log, nothing's happening there. I don't know why. Equals and try. There's something that's tripping me up here. And I'll take a look at it when I move you guys into this next one because should be able to do this. But this would be on the path to moving it to a one-liner. But it's 8:30, so let's pick the next one and get you guys working on that one, and then I will figure out what I'm doing wrong with that. We'll talk about it after we come back for the next challenge. All right. Let's see here. So we just did initials. Let's take a look at range. All right, write a method that takes in a minimum and a maximum integer and return an array of all the integers in between in ascending order. So notice that this is non-inclusive, right? So if we put it at 3 and 7, it's all the numbers in between, not including them. -4 to 1 gives us -3 to 0. And we've got some hints down here, right? And so we've got over here. So I will go ahead and pause the recording unless, do you have any questions about this one? Okay, I'm gonna pause the recording. All right, welcome back from the range challenge. So as I said, I was going to take a peek at what I was doing wrong on the initials one-line solution. I figured it out. It was a combination of doing two things wrong. The first thing is that I cannot use a for each with trying to solve this, because for each, it doesn't matter what I do inside my callback function. At the end of the day, it returns undefined. So when I had a for each in there, basically at this point, from here to here, with that being a for each, resolves to undefined, regardless of what I did before that. At the end of the day, it resolves to undefined. And I was trying to join it, and you can't join on undefined. When I switched it to a map, it wasn't doing what I was looking for either, because I had the curly braces in here and was doing it as a multi-line. And the way .map works is, and not necessarily just .map, but as a callback function in general, is that if I have a multi-line callback function, my return is no longer implicit. You have to make an explicit return, and I didn't put the return in there. Right, so this returns true, but also what I can do is get rid of the curly braces and pull everything back up onto one line. And now within this callback function, even though it doesn't say return right here, it is implicit in the fact that it is a one line function. And so I still get true for all of these as well, right? So this, like, we can loop through it, we can split, but this absolutely, and even though it's down on multiple lines, I just did that for to make it easier to read. Technically, this would be like a one line solution or a one line function here. Right, so I will actually comment this out and take that and chop it, put it down here, and we'll say one line solution. And uncomment this stuff, fix the formatting, we'll run it just to make sure it works. All right, still good to go. Okay, so it's 8:42. We'll go through this one. I imagine I'll be done around 8:50-ish or so, so we might end class a couple minutes early this evening. Or again, as always, I'm more than happy to answer any questions anyone has. So let's go ahead and take a look at this one. So let's go ahead and grab this. Right, and throw this up here. And let's take some examples. In a couple of different ways to solve this. I noticed you guys were working through it in the breakout, that you were able to solve it by adjusting your count. You could also have been inclusive with your count and then just popped and shift the first and last value off it at the end before you return it. But I like the way you guys solved it by just being ahead of it right when you were setting up your initial loop, right? So we get two parameters, right? So we get both our numbers and represent the min and max of our array, not inclusive. I guess I'll just say exclusive. All right, and we're going to return one thing, which is an array of all of the numbers between our min and max values. And we can say C below. All right. And so I need a array to hold all of the numbers and min max. pushes each integer into my result array. And then I can return my array. Oops. All right, so let's go ahead and take a look here. So we can say console.log min and max. All right, there's my numbers. So, excuse me. And say let array equal an empty array, and we can say for let I equal min plus 1. Right, and then sorry, I less than max and I plus plus. Right, and so if we do a console.log of I, right, 4, 5, 6, right, 3, and 4, 5, 6, and 7, and then -3 through 0, -3 through 0. So that all looks good to me. And so instead of console.logging, we can just say array.push. And console.log anything here, so console.log array. So that looks pretty good to me. And then we would also just need to return array. Sorry, that, this, we will move this down here. Right, 4, 5, 6, -3, -2, -1, 0. So that looks like a good solution to me. All right, so it is 8:47. That will probably be the last challenge for this evening because we won't have enough time to do another one. Any questions? That we got through quite a few challenges tonight, right? We did 1, 2, 3, 4, 5 challenges. We finished up on range, which put us right here. So we've got the ones on the last page here. Back of the line is a good one. Largest error is okay. Repeated characters is another good one. And so we'll start in on those on Wednesday. And then Thursday, and we may do another recursion one on Wednesday, and then Thursday we'll do another recursion one. We'll do employee data. Again, if anyone has ran into any challenges on the outside that they want to go over that they think would be good for class, feel free to bring them. If not, I can always, if we run out of stuff to do on Thursday, I can always go grab a Code Wars challenge or something like that, or Elite Code one, and we can work on that in class as well. But that's pretty much it for tonight. Does anyone else have any questions for me about any of the challenges, anything else that we want to talk about before we punch out for the evening?
I'm good.
Anyone else?
Good to go here. Thanks.
Cool. I'm going to pause the